One last example here of modeling with quadratic functions. And we're looking at this example here. It says, from the time Mark Twain wrote The Celebrated Jumping Frog of Calaveras, and I think it's Calaveras County, is what I remember in the book, if you've read that, in 1865, frog jumping competitions have been growing in popularity. The graph shows the function y equals negative 0.029x squared plus 0.59x, modeling the height of one frog's jump, where x is the distance in feet from the jump start. So let's go to our calculator and let's go to the y equals feature and type that in. So we're going to go to y equals, and we're going to type in negative 0.029x squared plus 0.59x. And we may or may not be able to see anything on here, but we can see a good portion of it. But what I want to recommend is that we use the zoom 0 feature. I'm not going to scroll down because the calculator is being temperamental today, but zoom 0. And that didn't help us very much. But if you notice here, we need to find some values, and maybe we can come up with some. For instance, when we go to the window, our x minimum is 0, and we can't see on this graph, it's going to be a little bit different picture here, we can't see where it lands. And right now in our graph, we have this going over to 10. How much farther do you think we want to put in there? Let's put it to 20. And if we can't see the end here in a minute, then we'll go back and change it. Once again, on the y-min, we can start with 0. And we can see everything we need. I might put a couple more in. I might make it 5. But you don't even have to change it because you can see it. And let's see if we can see everything on our picture. Almost. So what do we want to change it?
No, wait.
Let's go to 25 here for our window. Instead of 20, we were almost there. But with 25, we can see everything that we need. We can see the maximum value on here. We can see the 0 of the function on here. So now that we've got that, what did we put into our calculator? We put 0 in for the min. We ended up with 25. I don't know, did I leave my scale of 1? I think I left the scale of 1. The y-min we also have as 0. I moved it up to 5. If you left it with 3, leave it as 3. And your y-scale is 1. So now we have a good picture. And it says, how far did the frog jump? And that's why we really did need to change this so that we could see where the graph crosses the x-axis. And when we do that, we're going to type in second, trace, and 0. And unfortunately, for the video watchers as well, this takes me forever to move this cursor. Let me go there. And then we need to get the other side. We did the left bound, so now we're doing the right bound. When we do the right bound here, this y value on our screen needs to be a negative. We need to have the cursor, the cursor above the x-axis and below. So I have to watch the y value at the bottom of the calculator screen. As we scroll through here, we're getting the negatives now. So I've got a negative y value at the bottom of the screen, so I'm going to hit enter. And our 0 of our function is going to be between those two lines. When we hit enter a third time, we'll get our value here, which is 20.34 if we round to the nearest hundredth. 20.34 feet. If we were finding this algebraically, what we would have to do is we would have to factor. And it's not going to be the easiest thing to factor. But ultimately, for a few of you who don't have the calculator, if you look back at the equation, what happens is you have a greatest common factor, and it's x. And when you factor out that x, we get negative 0.029x plus 0.59. And then you can set each of those factors equal to 0. But to determine how high the frog jumped here in part C, since we're thinking about how we would do it without the calculator, we would use the x equals the opposite of b divided by 2a. This is for the people who don't have the calculator. And then we would plug that answer back into our y equals negative 0.029 x squared plus 0.59x. Which, if you have the graphing calculator, is going to be a much simpler process in the scheme of things, because we're going to go second, trace, and maximum. Highest value. Again, sorry to people watching the video because it takes me a long time to scroll through here to get to our left bound. Inspire calculators are much quicker. But I'm almost there. And again, I have issues here when I start doing that, and it's not going to work. And I just messed it up, so even worse here.
Oh no!
So we'll try that again. I don't know where my cursor's going to land. Second, trace, and 4. It's much easier to use your calculator when you're sitting at a table or a desk. But there's the left bound. I'm on the right track now. My smartboard's going to freak out. Yippee! Enter. And then finally here we enter. And what we see here, what the question's asking again, is how high the frog jumped. Which one of those two numbers is how high the frog jumped? It's going to be the y. It's going to be 3 feet that the frog jumped. And then lastly, how high is the frog 2.25 seconds into its jump? Well, once again, we're going to take the y equals the negative 0.029, and we're going to fill in 2.25 in for the x plus 0.59 times 2.25. And when we do that, I'm going to use my store button. So second mode to get out of there. So 2.25 store x, enter. And then our function is negative 0.029 x squared plus 0.59 x. And when we press enter, we should get our value that we need to round to the nearest hundredth. So we're looking at the 0 here to round the 8. That's going to keep our 8 and 8, and we get 1.18.